So let's start today's session. I think I am audible, right? Yes. Am I
Yes,
audible?
ma'am.
Okay, fine. Okay, fine. So today we will talk about the assignment 10, week 10, previous year question papers. I mean the previous year assignments. So this is the first question. Under the transformation, mu goes to mu prime, which is mu prime equals to mu minus del mu lambda, where lambda is a scalar function. Mu changes to which one? Okay, so this is the first question, and we will write that one. Okay, so here it is already mentioned that mu prime equals to mu minus del mu lambda, right? So mu prime equals to mu minus del mu lambda, right? Yes. So what will be the value of mu under this transformation? That means we have to calculate mu prime mu prime. What will be this value? So if I just write here mu prime, then it will be mu minus del mu lambda. Now if I just write here mu minus del mu lambda and mu minus del mu lambda. Okay, so it will be mu minus mu del mu lambda minus del mu lambda mu plus del mu lambda into del mu lambda, right? So it will be nothing but mu minus plus, let me write here plus del mu lambda, then del mu lambda minus, you can see here mu del mu lambda plus del mu lambda into mu. So this is nothing but, I am just writing here this part explicitly, del mu lambda into mu. So I can definitely write like that mu del mu lambda plus mu del mu lambda, right? Because it is just a multiplication. Then also I can write here as it is, I mean in general we can't write like that, but yeah, as it is del mu lambda, see mu del mu, so we can write here interchangeably that mu del mu also. Then what will happen here, it will be come out as 2 into mu del mu lambda. So if I just write here explicitly the expression mu prime, then it will be mu, sorry, it will be mu plus del mu lambda minus 2 into mu del mu lambda. So now you just see the option, which one will be the correct one here. You can see here this one mu minus 2 mu delta mu plus delta mu lambda. That means our correct answer will be C. Just what we have to do here in that question, we have to just replace mu prime with mu prime, mu will be replaced by mu prime and mu will be replaced by mu prime. Then we are just putting these things together and we will just multiply that one with the help of 4 momentum multiplication. Nothing else is there. So we can just see that the correct answer will be the C1, as I already told you. Okay, so this is a very simple question. Now we will talk to the second question. Second question is, if mu nu is del mu minus del nu mu under the transformation mu prime, in the right now the transformation is like mu plus del mu lambda plus del mu chi, where lambda and chi are differentiable scalar functions. Then if mu nu changes to which one, right? So this is the question. So that means, and there are 4 options. Is it if mu nu plus mu delta nu lambda plus mu delta nu lambda chi, and or is it if mu nu minus mu delta nu lambda, or if mu nu, or if mu nu plus del mu lambda del mu chi. This type of 4 options are there. So we have to choose that which one will be the correct option. What is the question here? Question is nothing but we have to replace mu and nu with the help of this transformation equation, and we will write what will be the value of if mu nu here. Okay, so first of all we are going to write F mu nu. F mu nu is what? F mu nu is del mu a nu minus del nu a mu, and a mu is changing as a mu prime equals to a mu plus del mu lambda plus del mu chi, okay, plus del mu lambda plus del mu chi. So this is the a mu prime. Now what we will do, we will just change that one, yes, this one, right? We will just change that one, that f mu nu prime. What will be f mu nu prime? It is nothing but del mu a nu prime minus del nu a mu prime. So I am just going to write here, a nu prime is what? A nu plus del nu lambda plus del nu chi, because you can see that we have written here a mu equals to a mu prime equals to a mu plus del mu lambda plus del mu chi, and as mu and nu are dummy indices, we can replace that one. I mean, mu can be replaced by nu easily, so we can write like that, del mu a nu plus del nu lambda plus del nu chi minus del nu a mu plus del mu lambda plus del mu chi. So now what we will do, we will just calculate a little bit. A mu plus, you can see here, del mu right? So del mu lambda plus del mu chi minus del nu a mu plus minus del mu lambda minus del mu chi. Now you can definitely see that del mu lambda can be written as del mu lambda also, and similarly for x also, like for x also del mu x can be written as del mu x, not x, chi, sorry. So then what will be the value of f mu nu prime? You can see here, del mu a mu. Okay, now I am just writing here this one. So I am just writing here this one at the very first, so that will be minus del nu a mu, then del mu lambda, so del mu lambda plus del mu chi minus, you can see here the minus is there. Where is the minus? Here. Del mu lambda del mu chi, and I told you that it can be interchanged. That means del mu lambda so del mu lambda minus del mu chi. So now obviously this one and this one will cancel out, this one and this one will cancel out. Then what will be left here? Del mu a nu, that will be nu, because here I think nu was there, na? Oh, I wrote wrong, here it is nu, so it will be nu. So del nu minus del nu a mu. So f mu nu prime is del mu a nu minus del nu a mu. It is exactly f mu nu, right? Because in f mu nu expression we had del mu a nu minus del nu a mu. So we can definitely tell that if our a mu prime is like a mu plus del mu chi plus del mu lambda, then also we can have f mu nu prime equals to f mu nu. So what will be the answer for this question? The answer will be C, f mu nu. That means f mu nu changes to again in f mu nu. F mu nu changes means f mu nu prime, and f mu nu prime we have calculated as f mu nu. So f mu nu prime will be f mu nu. That means our answer of that question will be C option. Okay. So there is one conclusion from this question, let me tell you that if a mu prime is a mu plus some scalar, I mean the differentiable scalar, as well as with the help with in the addition of some other scalar differentiation, but still the f mu nu does not change its nature. You can see in the previous week, I think we have written here one thing, that a mu prime was a mu plus del mu lambda. At this position also f mu nu prime was f mu nu. Okay, so and right now also you can see that a mu prime, if I write here a mu plus del mu lambda plus del mu chi, then also our f mu nu prime is equals to f mu nu. So that means whenever we are adding scalar differentiable scalars with vector potential, our f mu nu will not change. Okay, so our f mu nu will be exactly invariant even we add something as an addition of a scalar differentiable scalar with a mu. So that can be a conclusion from that question. Okay, so let's start question number 3. The question number 3 is a little bit lengthy, so we will do that slowly. The wave function of electron with mass m and electric charge E satisfying Dirac equation is taken as psi equals to root over 2m 1000 e to the power minus I p dot x, where p is its 4 momentum. The Dirac matrices are given by gamma 0, gamma 1, gamma 2. The 4 vector current density J mu equals to rho j associated with this electron is how much? And there are 4 options. J mu equals to minus E 2m 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 2m, J mu equals to minus E 2m 0 0 0, J mu equals to minus E 2m 0 0 2m, J mu equals to minus E 2m 2m 0 0. So now coming to the question again, here they have taken one eigenstate which is known as psi, and they have told that root over 2m 1000 to the power minus I p dot x is the state value. And what is basically e to the power minus I p dot x? Let's say if p dot x is there, that means it is nothing but p mu x mu. It is 4 momentum as well as 4 position, right? Now p mu can be written as like p mu p0 and t minus p vector dot x vector. So now we have to calculate J mu. J mu is what? J mu is rho j. So I have written here J mu equals to rho j. So rho j means rho will be like J0, J1, J2, J3. J0 is rho and J1, J2, J3 will be J vector. So I have written whatever it is given in that question, that what is psi, what is gamma 0, what is gamma 1 and what is gamma 2. Now we have to calculate J mu rho j, that means J0, J1, J2, J3. So first of all, what is basically J mu expression? J mu is the electron current density. So if it is electron current density, then the expression will be minus E psi bar gamma mu psi. And so what is psi bar? Psi bar is psi dagger gamma 0. So if I just put that expression to this, then it will be minus E psi dagger gamma 0 gamma mu psi. Now coming to psi J0 expression. J0 means rho, which is nothing but minus E psi dagger gamma 0. Here in replacement of mu we will put 0, that means it will be gamma 0 psi. So minus E psi dagger gamma 0 whole square into psi, and we also know that gamma 0 whole square is equals to 1. So minus E psi dagger 1 into psi, which is minus E psi dagger psi. Now here, as we told that psi is root over 2m 1000 and then e to the power minus I p dot x. So this is psi, and if I write psi dagger x, then it will be like root over 2m 1 0 0 0 because psi dagger means dagger will be like transpose, conjugate transpose, right? So as there is no complex number, that will be simply transpose, and there this term will be there from psi, and you can see that this e to the power minus I p dot x will not be there because one will be e to the power plus I p dot x and another will be e to the power minus I p dot x. So that will cancel out. And yes, 1 root over 2m term will also be there. So what is the answer then? The answer will be like 2m, root over 2m and root over 2m will give us 2m. And then you can see that this is like 1 and then all the terms will be 0. So which is nothing but 2m. So psi dagger psi is 2m. And what is the question? So that means J0 will be rho, which is minus E psi dagger psi, which is minus E into 2m. So we got J0, which is nothing but rho we got. So now we have to calculate J1, J2 and J3. That will make J vector, right? So, okay, I don't have any space here, but I can write here also as well, no problem. Yes, I can write here. So J1 can be written as minus E psi bar gamma 1 psi, because that was psi gamma mu psi. Now it will be like psi dagger gamma 0 gamma 1 psi, right? So psi dagger into gamma 0. Now what will be the value of J1 in this case? Like we can write gamma 0 and gamma 1 explicitly, and after that we can multiply that one with this expression, but that will give a very long expression. So what we will do here, we will simply write that psi dagger, at the very first we will do psi dagger gamma 0. So you know that psi dagger is a, see, psi dagger is what? Psi dagger is this one, 1 0 0 0, right? So it is nothing but 1 by 4 matrix, and gamma 0 is what? Gamma 0 is 4 by 4 matrix. So if we multiply gamma psi dagger with gamma 0, then it will be like whatever will be there, then it will be nothing but, you can see here 1 by 4 matrix, because 1 by 4 and 4 by 4 multiplication will give you 1 by 4 matrix. So this will be the psi dagger gamma 0 expression. So now we have to just calculate 1 by 4 will be what? I mean 1 by 4 matrix will be what? So psi dagger gamma 0, let me first write 1 0 0 0. I am right now omitting that root over 2m part, or we can also write here root over 2m part. And what is gamma 0? Gamma 0 is like 1 0 0 0 0 1 0 0 0 0 minus 1 0 0 0 0 minus 1, and also there is also minus e to the power p dot x is also there. So if I just multiply that one, then it will come as e to the power minus I p dot x. Then you can see, if I am just writing here, then it will be nothing but 1, see 1, then all the things will be 0, right? Then 0, okay. So what will be the answer here? The answer will be like, okay, so this will be 1 by 4 matrix. So there will be no component. That means the matrix will be like to the power minus I p dot x 1 0 0 0. So this will be the answer for that psi bar gamma 0. Now if let's say psi bar gamma 0 is multiplied with gamma 1, so psi bar gamma 0 is multiplied with gamma 1, that means you can see that, I mean definitely we can tell whatever is this in that 1 1 position, it is 1 for psi bar gamma 0. And also if in gamma 1 matrix the 1 1 element is non-zero, then only we can have a non-zero value. But what is gamma 1 expression? Gamma 1, if I just write here a little bit, then it will be like 0 0 0 1 0 0 1 0 0 minus 1 0 0 minus 1 0 0 0. So we don't need to bother about this whole matrix, because you can see that the 1 element of gamma 1 is giving 0. So that means if it will multiply with, let's say, psi dagger gamma 0 into gamma 1, then it will automatically give us 0 value, because this 1 and this 0 will give us 0, and rest of the all other 3 terms are 0. So that's why obviously it will give a result of 0. So we can have the conclusion that J1 is psi dagger gamma 0 gamma 1, and there was minus e was there, so it is nothing but 0. So J1 is 0. Similarly, if I tell you that J2, so till now what we done, we did like minus e into 2m, then J1 is 0. Now what about J2 and J3? I'm just going to write here little bit. J2 is what? Minus e psi bar gamma 2 psi. So minus e psi dagger gamma 0 gamma 2 psi. So psi dagger gamma 0, it is giving as like e to the power minus I p dot x 1 0 0 0. So if by anyhow our gamma 2 has 1 1 component as 0, then it will give us 0 value, right? So we can see here that gamma 2, see here also in gamma 2 also we can have the 0 value. This is 1 1 term, in 1 1 term also we can have a 0 value. So that's why our J2 will also be 0. Similarly our J3 will also be 0. Okay, so now what we will write here, the J3, okay, so how J3 can come as a 0, because you can see here okay, gamma 1 gamma 2, and there should be one gamma, yeah, gamma 3 should also be there. It is not mentioned here. Gamma 3 will be like 0 0 1 0 0 0 0 minus 1 minus 1 0 0 0 0 1 0 0. So in that case also you can see that 1 1 element of that gamma 3 is 0. So that means if I write here J3 also, the J3 will be nothing but minus e psi dagger gamma 3 psi, which is minus e psi dagger gamma 0 gamma 3 psi. So that will give us 0 value. So now we can conclude that our J vector will be 0, because J1, J2, J3 all the 3 terms are 0. So J will be nothing but minus e into 2m, then 0 0 0. So this is the B option. So that's why we can tell that the correct option for this question will be, for that question will be B, that is J mu equals to minus e 2m 0 0 0. So this is the question, and I hope it understandable. So we will go to the next one. Yes. So this is the question number 4. So what is this question? The question is an electron with 4 vector current density J mu equals to rho J is interacting with proton at rest. We have to focus on this line, proton at rest. The electrolytic potential associated with the proton is represented by the scalar function phi. The transition amplitude representing the interaction of the electron with the proton in this case may be written as. There are 4 options. Tfi equals to minus I integration rho phi minus j dot grad phi d4x. Tfi equals to minus I integration j dot grad phi d4x. Tfi equals to minus I integration rho phi d4x. Tfi equals to minus I integration rho phi minus del phi del t d4x. So if this is the question, and what is there in that question? In that question, the J mu is given here as rho J, and the proton is taking us at rest. So what is the advantage of this line? I will tell a little bit later. The first of all, we just want to tell you that what is given here, the electrolytic potential associated with the proton is represented by the scalar function phi. Now what will be the transition amplitude? So Dr. Pavlos has already mentioned that what will be the expression for that transition probability TIF. So what will be that one? Sorry, TFI. So what will be TFI? TFI is nothing but minus I integration J mu A mu D4 X. Okay. So now what is A mu here? The text is written as proton is at rest. That means what? That means our A mu is like if there will be some A0 and A1, A2, A3 will not be there because proton is at rest. And what will be A0 here? You can see that in that question it is already written. The electrostatic potential associated with the proton is represented by the scalar function phi. That means electrostatic potential is nothing but A0, which is written as phi. So what will be A mu here? It will be phi 0, 0, 0. Okay. So this will be the A mu expression. Now if I just put this A mu expression with that J mu value, then what will be the answer here? T if I equals to minus I integration J mu dot A mu D4X. Now see, J mu dot A mu can be written as J0 A0 plus J1 A1 plus J2 A2 plus J3 A3, right? Now in that A mu expression we got the expression that is phi 0, 0, 0. So what about the A1, A2, A3? These all are at 0 value, right? So only J mu A mu will be J0 into phi because A0 term is phi. So if I just going to write here the expression, then it will be TIA phi minus I integration J0 into phi into D4X. Now what is J0? Okay, so in J expression we know that J is rho into J vector. So what will be the J0? J0 will be nothing but rho. So obviously TFI will be minus I integration rho into phi D4X. That will be the expression for this question. Now we have to see which option will be the correct one. You can see here the correct one will be, yes, this one, C. TFI equals to minus I integration rho phi D4X. So very simple, we just need to write the expression for the transition amplitude, probability amplitude. Transition amplitude representing the interaction of the electron with the proton in this case. And that will be rho into phi D4X. Okay. Okay, so let's start the question number 5. Consider the process E minus P1 plus E plus P2 going to gamma Q going to P mu minus P3 plus mu plus P4 mediated by photon where Pi and Q are the four momenta of the corresponding particles. The wave functions of the particles as denoted by the subscripts are psi E minus equals to E1 e to the power minus I P1x, psi E plus equals to V2 e to the power minus I P2x, and psi mu minus equals to U3 e to the power minus P3x, psi mu plus equals to V4 e to the power minus I P4x. Which of the following correctly represent the transition amplitude of this process? And the options are TFI equals to minus I e square 2 pi to the power 4 delta 4 P1 plus P3 minus P2 minus P4 U3 gamma mu U1 minus 1 by Q square V4 gamma mu V2. TFI equals to minus I e square 2 pi to the power 4 delta 4 P1 plus P2 minus P3 minus P4 V2 gamma 5 U1 minus 1 by Q square U3 gamma mu V4. TFI equals to minus I e square 2 pi to the power 4 delta 4 P1 plus P2 minus P3 minus P4 V4 gamma mu U1 minus 1 by Q square U3 gamma mu V2. And the fourth option is TFI equals to minus E square 2 pi to the power 4 delta 4 P1 plus P3 minus P2 minus P4 U1 gamma mu V2 minus 1 by Q square V4 gamma mu U3. So these are the four options, and we have to write which one is the correct one. So let us first write whatever it is given here. E minus plus E plus is going to mu minus mu plus plus mu minus, and it is like it will gamma then mu minus plus mu plus. Okay. So if I just write the Feynman diagram for this equation, then it will be like E minus E plus mu minus mu plus and gamma. So now if you just see here, then okay, so I'm just right now going writing the momentum here. You can see here P1 P2 P3 P4 and Q. Okay, so P1 P2 P3 P4 and this one has Q. Is it correct? P1 P2 P3 P4. Okay, yes. And one more thing is there, V1 V2 this one expressions. So what are these expressions? The expressions are psi E minus U1 e to the power minus I P1x psi E plus it is V2 e to the power minus I P2x psi mu minus is equals to U3 e to the power minus I P3x, and then psi mu plus is V4 e to the power minus I P4x. Now you can ask me one question, that why V2 V4 are there and why U1 U3 are there. I think it has already mentioned by Dr. Paulus very nicely, but still I am just writing here, like for the particles U1 U3 we are mentioning, and for antiparticles we are writing V2 V4. You can see here that E plus is the antiparticle of E minus, mu plus is the antiparticle of mu minus. So for the particle configuration we will use U1 U notation, and for antiparticle we will use V. Okay, so that's why you can see here when we are talking about E plus, then it will be V2 e to the power minus I P2x, and as well as when we are talking about mu plus, psi mu plus equals to V4 e to the power minus I P4x. Okay, so these are the things. Now what will be the expression for the TFI? So for the TFI expression, first of all we need to see that we need to see the momentum conservation here. So what will be the momentum conservation here? You can see here from that picture that our delta 4 should be like P1 plus P2 minus P3 minus P4. Otherwise the momentum conservation will not be conserved, like momentum will not be conserved here, momentum will violate, and it has already explicitly explained in the previous class also. So what will be the delta 4 here? Delta 4 will be nothing but P1 plus P2 minus P3 minus P4. Now we have to check which one is the correct one among these four options. Let us calculate first one. You can see that it is P1 plus P3 minus P2 minus P4. So obviously this one will not be the correct one. Now just check the second one. Second one is P1 plus P2 minus P3 minus P4. Maybe this will be a correct one. And again in the C option you can see that P1 plus P3 minus P3 minus P4. So it can also possible to have the correct one result. But now coming to the D option, you can see P1 plus P3 minus P2 minus P4, that is also not possible. So the by conservation of that momentum we can obviously cancel the A and D option. Now B and C option is there. Then how to calculate the how to know that which one is the correct one, B or C? Okay, So now you can just see here, that is a very simple one. Let's say I am having here gamma mu. So what is this one? This one you can see, this one I have written here for mu minus. For mu minus it was u3 and for mu plus it was v4. So u3 and for it is v4. So I am just rounding this thing. So the in that vertex the expression will be u3 gamma mu v4. In this vertex, I am talking about this vertex only. In that vertex you can see that u3 gamma mu v4 will be there. Now coming to these two options, you can see here there is also one vertex, there is also one vertex, but right now we are talking about these two vertex, right? I mean, in that vertex you can see that u3 gamma mu v4 and u3 gamma mu v2. So if it is v2, that means this one, then that this is, I mean, u3 gamma mu v2, this is not a vertex and this is u1. Okay, so that means our correct option will be the c1, b1. B1 will be the correct one, because you can see that the vertex correction will give us the correct result, which is u3 gamma mu v4. Now you can come to this vertex here, v2 gamma mu u1. Now you can see here, this is v2, this is gamma mu again, and u1, v2 gamma mu u1, that is fine. But this is not correct, that v4 gamma mu u1. Now check v4 gamma mu u1, v4 gamma mu u1. This is not a vertex, right? This and this will not make a vertex. Vertex will make like v2 gamma mu u1, that will make a vertex. Similarly u3 gamma mu v4, that will also make a vertex. So the b1 option will be the correct one. Okay, so now coming to the next question. Okay, so the momentum exchange q in the above process is given by which option? Okay, that is very simple one, because we have already written that one, that E minus E plus mu minus mu plus, and this is gamma. So like here it is P2, P1, P3, P4, Q. Okay, so now you can see here that obviously due to the conservation of the momentum, what I can write here, the Q will be equals to P1 plus P2, right? And as well as Q can also be equals to P3 plus P4, otherwise the momentum will not be conserved here. So the Q value will be like P1 plus P2, or it can also have the value P3 plus P4. So if I just go to the expression question again, the momentum exchange Q in the above process, whatever we are talking about, E minus plus E plus going to gamma, going to mu minus plus mu plus, is given by these options. And you can see here, give all the correct options. That means it can be more than one option also. Now here you can see the first option, P3 minus P4, that will not be correct. P3 plus P4, that will also not be correct. P3 plus P4, that will be correct. P1 plus P2, that will also be correct. So the correct answer will be C and D. Okay, so the momentum exchange for this process, which is denoted as Q, that can be written as P1 plus P2, that can also be written as P3 plus P4, because due to the momentum conservation we all know that P1 plus P2 is equals to P3 plus P4. That's why we have written in the previous question that P1 plus P2 minus P3 minus P4. So the delta 4 is giving what? Delta 4 is giving like, let's say delta 4 expression, I have already mentioned that one in the last class, but still, x minus x0 will be 1 if and only if x is equals to x0 and 0 otherwise. Okay, so that's why we can obviously write delta 4 P1 plus P2 minus P3 minus P4, and similarly from that energy conservation, momentum conservation also, I can also write like Q equals to P1 plus P2, Q Q equals to also P3 plus P4. Okay, so this is the case. Now yes, from that question I have already mentioned the correct option. The correct option is C and D. Okay, now coming to the next question. Yes, so this is the next question. Two monochromatic with single momentum and energy beams of particles A and B undergo scattering. In the laboratory frame, their three momenta are P1 is pz cap and P2 is minus 2 pz cap, where z cap is the unit vector along the z axis. Their energies in this frame are E1 equals to E and E2 equals to 2E respectively. Considering the normalization as defined in the lectures, refer lecture 37. What is the flux density associated with this scattering? Okay, and the options are like AF equals to 24 PE, 16 PE, 8 PE and 12 PE. So first of all we have to consider one scattering. You can see that two monochromatic beams A and B undergo scattering. So scattering will be how? Let's say it is A beam and this is the B beam, right? So this will occur as scattering. Now if you see the momentum here, the momentum of A is P into Z cap, momentum of B is minus 2 into P into Z cap. So let's take this one as Z cap, this axis. So this one will go as P into Z cap, P1 into Z cap, and this one will come as minus 2 into P1 into Z cap. Why minus? Because it is going to the opposite direction. Oh sorry, it is PZ cap. So this is PZ cap and it is minus 2 PZ cap. So obviously one will come this side and another will come this side. Now they are asking about the flux density. Yes, and obviously the energy is also given here. The energy is like E1 is E and E2 is 2E. Now what will be the flux density here? In that lecture of 37, whatever it is mentioned here, in that lecture sir has already explained very explicitly the expression for the flux density for the scattering case, but still I am just writing here a little bit. So flux density will be nothing but, let's say, mod value of V. Okay, VA, I am talking about A because we are talking about A and B particle. So VA minus VB, then 4 into EA EB. Okay, so now VA and VB, we can see that PP and PA and PB were opposite in direction. So VA and VB will also have the opposite value. So if I just put the mod value, then it will be like mod of VA plus mod of VB, because the momentum is opposite in sign for each, with respect to each other. So EA EB. Now you can see here, okay, VA VB is there. Now how to calculate VA and VB? So what is PA? PA is nothing but EA into VA, right? And PB is what? PB is EB into VB. So if I calculate here VA, then it will be PA by EA. Similarly, for VB, it will be PB by EB. So if I just put these values, then VA will be PA by EA plus PB by EB into 4 EA EB. So what will be the answer for that F? Okay, PA by EA plus PB by EB 4 EA EB. If I just do a mathematical calculation little bit, then it will be like PA EB. Okay, so this one is nothing but the mod value. plus PB EA, then 4, because that EA will cancel out. So the answer is nothing but 4 into mod of PA EB plus PB EA. Now in that question, what they have given like P1, I mean like PA is P into Z cap, PB is minus 2 into P into Z cap. Similarly, EA is E and EB is 2E, right? So if I just put these values here, then it will be flux density will be 4 into E. Why E? Okay. Okay. 4 into P is P into Z cap, and it is the mod value, so that means we are not taking the direction here. E into P, then plus, you can see here, mod PB into EA. So mod PB is how much? This is 2P and this is 2E. So okay, sorry. So this is EB, right? So EB is 2E. EB is 2E. And this is only E. Because it is E. I mean EA. So 4 into 2EP plus 2EP. So what will be the answer here? You can see that 4, 2 will come as 4, 16 EP. So the flux density will be 16 PE. This is the correct one. So now coming to the answer question again. In that question you can see that the option is B here. F equals to 16 P into E. So what we have done in that question, we have just taken two monochromatic beams of particles E and B, and we do that scattering for these two particles, and their momentum of these two particles are given, as well as the energies are also given. So we have to just calculate what will be the flux density associated with this scattering, and it comes out that the answer is 16 P into E. Okay. Now coming to the 8th question. In the above question, that means 7th question, what is the relation between the masses of the particles? What will be the relation between MA and MB? Basically we are talking about A and B particle, right? So there are 4 options. M2 equals to M1 by 4, M2 equals to M1, M2 equals to 2M1, M2 equals to 4M1. So which one will be the correct answer? So similarly I am just doing this very same calculation here. This is PZ cap, this is minus 2PZ cap, EA is E, EB is 2E, right? Now okay, so flux density we have already calculated. So if PA is PZ cap and PB is minus 2PZ cap, then we can simply write from that mass energy radiation calculation of the Einstein equation. Then it can be written as E1 square will be, EA square will be PA square plus MA square, right? Similarly, EB square equals to PB square plus MB square, and we have to calculate the relation between MA square and MB square. Okay. So EA is what? EA is E. So E square is PA square. PA square means P square plus MA square. And EB square is what? This is 2E whole square equals to 2 into P whole square plus MB square. So now obviously definitely we can write here P square plus MA square. And the next one is 4E square equals to 4P square plus MB square. Now just we have to put the value here, 4P square plus MB square. What I did here, I just simply put this E square equals to P square plus M square to this expression. Simple. Then the answer will be coming out as p square, 4p square plus 4 me square equals to 4p square plus mb square. So the answer will be like, you can see here the 4p square is cancelling out. Then the answer will be like 4 me square equals to mb square. Yes. So obviously mb will be 2 into ma. Now in that question they were mentioning that mb is m2 and ma is m1. So by comparing these two, we can write here m2 equals to 2 into m1. Okay, so this is the answer. So I think this is okay, this is done. So for today's lecture we have just learned about the questions, like we have learned about the flux density of a scattering process. We have learned about the mass relation between these two beam, monochromatic beam, and then previously what was there, we have also learned that okay, how to calculate the momentum exchange of a scattering process, and as well as the what will be the TIFI for this scattering process. And then we have also calculated, yes, TFI transition amplitude for one electron with 4 vector current density with the scattering of proton, I mean with the interaction of proton. Then again we have also calculated how to calculate the vector current density for that electron vector current density J mu, which is rho J for that particular psi, and with the help of gamma 0, gamma 1, gamma 2, gamma 3. And the next one was like, okay, so under the transformation, under the gauge transformation, a mu prime equals to a mu plus del mu lambda plus del mu chi, what will be the answer for that f mu nu? And then yes, so similarly the gauge transformation, a mu prime will be a mu minus del mu lambda, then what will be the value of a mu? So these questions we have covered in today's assignment questions. Okay, so if you have any question, then you can ask me, or otherwise we will stop today's session. So we will stop today's session, and we will meet in next class on Sunday, I mean next Sunday. Okay, till then, bye bye everyone.